let me take this this chance already to thank you again. I'm so happy to have you here again, my friend. And I hope you have a wonderful presentation for us as well.
For me.
For us as well. Thank you so much, man. Pessoal, nós vamos dar prosseguimento com a apresentação do Enrico. Nós estamos extremamente felizes de ter o Enrico novamente palestrando no evento para vocês. Para quem não sabe, o Enrico foi nosso keynote speaker ano passado. Então, nós gostaríamos de, inclusive, agradecer a Elastic, que é a nossa patrocinadora, que nos deu a oportunidade de ter o Enrico novamente conversando com o nosso público. Nós vamos começar a atividade, então. Lembrando a todos e a todas, por gentileza, façam o double check aí de microfone e câmera, para que a palestra transcorra sem maiores problemas, tá? E, posteriormente, o Enrico vai abrir para as perguntas, e sempre lembrando, se alguém precisar de ajuda, se ficar complicado de falar inglês, a gente pode ajudar, a gente pode dar uma força, tá bom? Então, uma boa palestra a todos. Enrico, my friend, have a good one. And if you need anything, I'll be watching silently here, and I'll come running to rescue. Okay?
Okay. Thank you very much. Thank you very much, Galvao.
Thank you. So, have a good one.
Thank you. So, good morning, good afternoon, good night, whatever you are watching this presentation. I'm very happy to be here at the PHP Conference Brasil 2020. For me, this is the second time, so I'm really appreciate last year in presence. So now we are online, but I also appreciate that, you know, all the team and Galvao give me the opportunity to speak again at this amazing conference. So my name is Enrico Zimuel. I work for Elastic. I'm principal software engineer at Elastic. I'm the maintainer actually of the PHP client to connect to Elasticsearch. And today I would like to present a talk that explains how to approach to Elasticsearch using PHP. So how to program, actually, how to use Elasticsearch using PHP. So this is the summary of my presentation. So we're going to talk, as I said, about PHP and Elasticsearch. I will explain briefly the architecture and the components of Elasticsearch in order to use with PHP. How to connect to Elasticsearch using PHP, how to perform some basic operation with Elasticsearch, because if you are familiar with Elasticsearch, it's basically a search engine. You can also call it a NoSQL database if you like. So there are basic operation in order to put data into Elasticsearch to get, to update and delete data. Almost the basic operation of the CRUD operation, basically, what every database offers. And also, this is actually the killing feature, I will say, of Elasticsearch, the search feature. And especially the fuzzy one, the ability to search terms that are not exactly the same of the term that you write in your search. I will also explain a little bit how it's possible to perform asynchronous operation using the PHP client. So basically, you can perform connection and execute query on Elasticsearch without blocking the execution of the PHP code. And I will also talk a little bit about the future work that I'm doing. I'm planning for the next major release of the client. So let's jump straight to the topics. So this presentation is basically about this project. It's an open source project. Is Elasticsearch-PHP under the Elastic umbrella of GitHub. This is the name of our company, and we basically expose all our software as a open source software. So you can literally go inside github.com/elastic and check it out, all our projects. So this is specific for PHP, of course. It's basically an updated version, and each time we release a new version of Elasticsearch, we release also a new version of the client, of course, for PHP. So right now, the last version is 7.10 of Elasticsearch. So we have also the Elasticsearch PHP client 7.10 release. We use a connection pool for cluster configuration because Elasticsearch is a search engine distributed. So it works using one or more nodes performing basically a cluster of a server. So using the Elasticsearch with PHP, you can basically say, okay, this is my cluster configuration. For instance, this is the list of my IP address of my nodes. So I can use the client, and the client will perform, will distribute the call of each API on each node. So it's a way to spread the communication from one client to all the nodes of your cluster. So this is very important. Basically, it exposes all the API of Elasticsearch because Elasticsearch it's a search engine database that works using API, using HTTP API. So theoretically speaking, you can use whatever client you want performing HTTP connection. But if you use the PHP client, everything is exposed as function of a client class. So basically, you will have an object that is the client class, and all the function, all the name, for instance, index, that is an API that put data into Elasticsearch. This index will be a function of the client class, basically. So we have this kind of mapping. So basically, when you execute a function, you are performing basically an HTTP connection to Elasticsearch, and the response will be the response of the function that usually is the body of the HTTP response. So we have some default serialization algorithm. One is the Json, because every communication between a client and a server, Elasticsearch is provided by JSON messages. So by default, we get this JSON string that is the response from Elasticsearch, and we serialize it using a default serializer that is an associative array. So the response basically will be an associative array that represents, that map the response coming from Elasticsearch. If there are some kind of API where you use the head HTTP method, and as you know, head, when you perform an head HTTP request, basically you don't have the body as a response. You get only the header and the HTTP status. So for these special cases of API, for instance, index exists. This is an API that you can perform in order to check if an index in Elasticsearch already exists or not. Basically, the response of the client will be a Boolean value, so true or false. But this is very specific just for the add HTTP request. The majority of the function we will have as response, as I said, a JSON that is serialized into an associative array. We, of course, we have a default serializer, but we provide also a serializer interface. That means if you want to change the output, instead of an associative array, you can have, for instance, a custom object, a custom class for your project. You can just implement a specific serializer, and when you initialize the client, you can pass this configuration to the client. So basically, the client will perform the serialization that you provided, your custom serialization. By default, as I said, everything is managed by associative array. In case of HTTP errors, for instance, you can have a 404 exception, a 404 error, HTTP. So this is the response from Elasticsearch. The PHP client will throw a specific exception. That every exception specific, like the missing 404 exception, is basically extends an Elasticsearch exception. So with a try-catch paradigm in PHP, you can easily, you can write a try and perform an API function in the client and catch possible, errors like missing 404. So for instance, if you are getting an index, if you are searching for an index that does not exist, the client will perform a missing 404 exception, and you can manage using the try-catch of PHP. All the endpoints of the client are generated using a REST API specification of the Elasticsearch project. So basically, if you go into the Elasticsearch project itself, that is a Java software, inside this implementation, there are some specification about the REST API. So for each API that Elasticsearch exposes, there is a specification, of course. And we use this specification, we parse this specification in order to update the client. So that means every time we release a new PHP client for Elasticsearch, this is completely aligned, is 100% aligned with the version of Elasticsearch. So this is also important to mention. And of course, we provide a lot of testing in order to test the PHP client. So we have, of course, unit testing, integration test, but more important, we have this Elasticsearch YAML test that is a set of tests that are used by Elasticsearch itself, so by the Java project, in order to test the Elastic software. And we use in PHP the same environment. So we basically read this YAML tests, and we are talking about more than 2K of tests, so a lot of tests, in order to basically use the PHP client to perform all the HTTP requests to Elasticsearch. So we are pretty sure that everything will work fine. It's a quite popular project, I would say, in the PHP community. It's more than 40 million of installation from packages.org. And this is just the statistics about the history. And as you can see, in the last year, we grow a lot. We are almost 45K installation per day. So it's quite good number. So it's quite popular. That's good. That means a lot of people are using Elasticsearch. That is, again, an open source search engine. As I said, all the function in the client are exposed, all the API of Elasticsearch are exposed using functions in PHP. So this is just a table. I just put a couple of examples here. So if you have for instance, the index API, that is basically an HTTP put with this URL, you need to perform in PHP, you just need to actually call a function that is index. So we use the same name, of course, providing a single parameter. So this is an associative array that contains all the specific parameter for the index. For instance, in this case, the target, the ID, and also the body. Of course, if you need to put some information in Elasticsearch, this information is basically a JSON, is a document JSON that you will put in the body. But this is inside this associative array. So it's quite simple, actually, to use the Elasticsearch PHP SDK, because you just need to pass the parameter as associative array and call the specific API. There is one-on-one mapping, so index is the index function, the bulk API is the bulk function. And for special API, like for instance, cluster stats, because Elasticsearch provides some API collecting into one name. For instance, you will have a cluster stats, cluster, and another API name again. So this is like a namespace. You can think about it. We provided this way, so we collect everything under one object. So you will have the cluster function here, that is actually a function without any parameter, and you will have the last name. So the stats is another function of the cluster object. So basically, the cluster in this case is a special namespace, is a special object of the client class that will provide all the specific API for only the cluster namespace. So in this way, actually, if you are using some IDE for develop PHP application, you have auto-completion. So it's quite simple to start typing the API name, and you will provide all the information by auto-completion, basically. Okay, so how to start using actually this Elasticsearch for PHP? Very simple. You use Composer, of course. So you can just require the library that is, the name is Elasticsearch/Elasticsearch, and this will provide the last stable version. So for instance, right now, as I mentioned earlier, the version is 7.10. So in your Composer JSON, you basically will have a new require of the latest version. In order to connect to Elasticsearch is quite straightforward. So basically, you have to use a client builder that is a class that we expose in the Elasticsearch project. So the client builder is basically a factory. If you are familiar with this design pattern, the object oriented. So basically, it's a class that you pass some parameter and will create an object for you. So the client builder has a create. So this is the first function to call, and a series of set. In this case, just one, the host. So in this case, we are just using one node. So in this scenario, we are connecting to one node of Elasticsearch. And I assume, for instance, that Elasticsearch is running as a server in the same instance where you are writing this simple PHP script, so it's localhost. And you have also the port. By default, the number of the port is 9200. As you can see here, this is string is passed inside an array because, as I mentioned, Elasticsearch is by design a multi-node database, multi-node search engine. So you basically here you can specify the list of all your nodes separated by comma. And the last function in order to create the client instance is the build. So if you create a client in this way, you are basically connecting to the localhost with this port. And after the build, you can just start using the client. For instance, you can perform an info. Info is a basic API that basically connects to the Elasticsearch server and provides some default information, some default response like I'm running Elasticsearch version 7.10. I'm running Elasticsearch using this IP address, this port. Basically the configuration information of your instance of Elasticsearch. And as you can see here, I'm just var dumping for this example, just to show how the results will be. So if you var dump the results, you will get an associative array like this. As you can see, there are some information like the name, for instance, of the Elasticsearch instance, the cluster name, the class unique ID, the version of the Elasticsearch, in this case is 7.10.0. The flavor, that means this is the open source version because we have two different versions of Elasticsearch. One is open source and the other is XPack. Actually, this is the name of the Elasticsearch, where you can basically install a new plugin and so on, and other information. So as you can see, the result, the $result here variable is an associative array. So by default, we will get always an associative array as result, as a response from any API. Imagine that you want to connect to a cluster of nodes and performing, for instance, a cluster health API. This is another statistics about the health of your cluster, how many nodes are running, if there are some failing nodes, and so on. This is the simple script that you can execute. So basically, if you see the difference, if you compare the difference with the previous slides, the only actually difference is the set host, that in this case is an array with 3 elements. In the previous slides, if you remember, we just put just one. So here, basically, you specify the IP address and the port where you're running your cluster. And the API, because I mentioned that we want to execute a cluster health API, you have just to provide the name of the namespace of the cluster function and the specific API name. That's it. And the results will be something like this. Again, an associative array. I just put in evidence here the number of nodes because I have 3 nodes here. So you can see that now the number is 3. Of course, if there is some failing node, this can be 1 or 2 even, or 0 if everything is down. Okay, the idea behind the Elasticsearch PHP is not just an HTTP wrapper, because I mentioned that Elasticsearch is a client-server application that works using HTTP API call. So in theory, you can, even in PHP, you can, I don't know, use curl in order to perform some HTTP call, or even a Ghazal. any HTTP client that you want to use in order to communicate to Elasticsearch. But if you are using the Elasticsearch official PHP client that we provided, you will get for free a lot of other features, like the connection pool. That is very important. So imagine that you have an Elasticsearch cluster with just 3 nodes with this IP address. So you have your PHP application, and you want to be sure that every time you perform an HTTP API request to your cluster, this API will go on Elasticsearch server number 1 the first time, the second time with Elasticsearch server number 2, the third time with Elasticsearch server number 3. And the fourth time, for instance, will continue in a loop. So we will back to server 1, to server 2, and server 3, and so on. So you want to distribute the traffic to your PHP client to all the nodes. So if you're using the Elasticsearch PHP client, this is for free, because basically the client, the first API will connect to server 1, the second to server 2, the third to server 3, and will loop using a default round-robin algorithm. So basically we'll go each time on all the nodes. In this way, you are sure that you are spreading your HTTP traffic using all your nodes in your cluster. And also, there is a logic that inside the client that say, okay, look, but if, for instance, the server 1 dead for any reason, what the client will do is just remove the Elasticsearch server 1 to the nodes, to the set of nodes, and will continue to use only the server 2 and the server 3. This is done automatically by the Elasticsearch PHP library. So you don't have to do nothing by yourself. So this is actually a very nice plus, because instead of doing manually the HTTP call, everything is managed by the client that had this logic inside. So again, this connection pool logic is very important. And another way that we provided, so we provide basically the connection pool, but we provide also this idea of selector. Because by default, as I mentioned, we are using the round-robin algorithm. This is a very well-known algorithm in networking. But we also provide a selector interface. So if you want to implement any kind of logic for picking up the nodes in a different order with a probabilistic algorithm, whatever you come out, you can just implement your selector, implement this selector interface, and you can basically inject this selector custom implementation when you create the client class. So we are providing, of course, a couple of implementation. As I say, the default is round robin that basically iterates over a set of nodes in a circular order. We provide also the sticky round robin, that is kind of specialization of the round robin algorithm. So basically, we use the current connection always, unless it's dead. It's not possible. It's dead. So if the connection dead, we use round robin otherwise. And we provide also a random selector that, as the word said, is a random selection of the nodes. So each time you perform an API, it should pick up a random number. In the example that I mentioned, we have 3 nodes, so we'll pick up a random number between 1, 2, and 3 each time. So this is basically the default implementation that we provided. But again, if you want to implement a different selector algorithm, you can just implement the selector interface. And when you do that, you can pass in the client builder. As I mentioned, we have a lot of set. We just show in the example set host, but we have also set selector. So if you use the set selector, you can pass your custom implementation, and you can use the client using your implementation. Of course, I don't know if you're familiar with the Elastic products, but we also have some Elastic Cloud. So basically, if you don't want to install Elasticsearch in your, by yourself and managing your infrastructure, you can even just open an account on the Elastic Cloud, and we will provide for you as many nodes you want, basically. And of course, there is a way to configure the Elasticsearch for PHP in order to communicate with Elastic Cloud. So basically, you have two options. One is using basic authentication. So you have to provide with a set Elastic Cloud ID, your Cloud ID. So this is an information that will, when you subscribe for an account in Elastic Cloud, basically you have this Cloud ID. And you will have also username and password in order to connect. So this is the basic authentication. Otherwise, you can use, and I strongly suggest to use this option, the API key. So basically, the API key, as you can see, you have always the set Cloud ID, and you have a set API key here where you pass two information. One is the ID, and the other is the key. If you go into the console of your Elastic Cloud, right now there is an API key that is just the basic 64 of these two information separated by colon. So basically, in order to get the ID and the key ID, you need just to perform the basic 64 decode. So you have to decode the basic 64, and you will get these two information that you can pass to the set API key. Anyway, this is just a way to connect the client using an API key instead of the username and the password. So I prefer also for security reason to generate when I work with the cloud environment an API key just for my application, and use this API key just for the application without exposing my username and password of the account of Elastic Cloud, of course. As I mentioned, everything, the communication between the client and the server is a JSON. So every HTTP is the body is a JSON. And in PHP, as you know, we have these two functions that are JSON encode and JSON decode. So for encoding and decoding information from JSON. Starting from PHP 7.3, we can use the JSON throw on error. This is a specific exception that the JSON decode or encode will perform if there are any errors in the JSON representation. So we'll throw basically a JSON exception. So this is the name of the new exception introduced in starting from PHP 7.3 in case of error. So basically, we provide in our implementation of the client, in the PHP client, if you are using, if this exception, JSON exception class exists, that means you are using a PHP 7.3, we are leveraging these options. So we are also, catching a JSON exception from the encode and the decode. So basically, we are trying to use the latest, feature of the PHP engine, of course, in the client. As you know, if you are familiar with JSON and the PHP, there is a specific cases that is still not really supported in a simple way, at least in PHP. This is the case of the empty JSON objects. So because in Elasticsearch, a lot of API uses this empty JSON object, it's the way that you can perform, that you can represent an empty JSON object in PHP is providing an empty object. But as you know, an empty object does not mean a lot in PHP, because there is not actually a hierarchy of object in the language itself, but we have a standard class. So if you are familiar with this, std class is the name of the standard class of PHP. So if you perform a new std class in PHP, you are basically creating an empty object in some way, because a standard class for PHP is just a class, an empty class that you can add, properties to that class on the fly. So that's the needs. So basically, this means if you want to map, if you have the needs to create a JSON object in PHP with an empty object like this, for this content, the value is an empty object, you can map this using these techniques. Basically, you have an associative array, as you can see, where the value is another associative array that query match content. In the case of empty JSON object, you need to put new standard class. So in this way, if you serialize this associative array into a JSON, the PHP engine, the function JSON encode, understand that this is an empty object, and we will translate into an empty JSON object. So this is the only way actually in PHP in order to map an empty object in PHP. So this is important to remember. Okay, let's jump a little bit in some basic API in order to put information into Elasticsearch, for instance. This is actually called indexing. So when you see index in Elasticsearch, that means putting data into Elasticsearch, indexing data. Of course, as I mentioned, Elasticsearch can be used as a NoSQL database. Basically, it's a document-oriented NoSQL database. So everything is managed by documents. So a document is a JSON, basically, it's a JSON document. So in this case, in this example in PHP, we are connecting to one node of Elasticsearch in localhost. We are putting some information in this $params, that is the associative array. So we want to create an index document with the name is my_index, my_index. We want to create a specific ID, specific document ID we want to create in Elasticsearch. The name is myID, and the content of the document is the body. So in the body, we have an associative array, just a key value. You can perform an indexing, calling the index API, of course, and this actually will connect to Elasticsearch and posting all this information into Elasticsearch. So if you perform this, and if the operation is successful, you will get back an associative array, as usual, in $results. And as you can see, there is a specific key that is results that contains the status of the results. So if you see created, that means that everything was okay. So basically, this is a very simple API. If you need to perform multiple documents, so if you want to index multiple documents in one single API, you can use the bulk operator. So the bulk API for Elasticsearch is a way to pass multiple documents in just one API call. Actually, you can perform not just indexing, but also deleting and update action. The format that is used is NDJSON. I don't know if you're familiar with this format. So basically, it's a JSON documents separated by a return, basically a new line. So you can have multiple document JSON separated by a new line, and this is named NDJSON. So how we can actually perform this kind of bulk operation in PHP? Very simple. So the first documents that you need to create is the parameter. So basically, as you can see here, we are a for loop of 100 elements. So we want basically to insert into Elasticsearch 100 documents. We need to create an array inside the body. So basically, as you can see here, the $params body is an array. So using this syntax, we are adding a new element at the end of the array. So as a first element, we need to put the parameter for the operation. So we want to index actually here. So we want to insert data into Elasticsearch. We are performing an index here. And you need to specify the name of the index, basically, that you want to create. And the second document is actually the body, the content. So this second element here is actually the body that contains the document that will be inserted into Elasticsearch. So here we have just a couple of key value. And when you have this array in memory, you can perform the bulk operator. So as you can see here, we are just calling one single API, that is the bulk API, in order to insert 100 documents in one shot, in one HTTP call. Okay, imagine that you want to read from Elasticsearch. You can perform a get API, very simple. You specify the index and the ID of the document that you want to read, actually. And the API is a simple get. So this will get back the document under the underscore source key element of the array. So in $results, you will have an underscore source that will contain the documents stored into Elasticsearch. In this case, if you remember, a couple of slides ago, we just used the test field ABC, and we just retrieve the same information, of course. If you are reading some index, some document that does not exist, you will get, as I mentioned earlier, a missing 404 exception. So you can, as you can see here, we are trying to read an unknown ID. So imagine that this string unknown ID is not present into Elasticsearch. You can just, using a try catch, as I mentioned earlier, very simple, you can just try to read the information from Elasticsearch, and if a missing 404 exception is thrown, you can just manage and do whatever you want. So very, very simple to manage error using the HTTP client. Of course, you can also update information, allowing you to completely replace the content of an existing document, or even to perform a partial update, so with just some fields. So imagine that you want to create a new field. You want to add a new field inside an existing document. You have to specify, of course, the number of the index, number of the ID, the specific document. And in the body, you can pass a new field using the doc key. Doc stay for documents, basically. And you can perform the update. And you will see that as a response, you will get back the new document that contain the previous value of the document, so the test field, and the new one. So as you can see, the new field is updated, is added to the document itself. Of course, you can also delete a document using the delete API. This is very straightforward, just passing the index and ID, performing the delete function, and you will get the results, as usual, inside the result key of the associative array. So in this case, if you see deleted, well, that means that everything was fine. Okay, so the most interesting, actually, part of using Elasticsearch is about searching a document. As I mentioned, Elasticsearch is a search engine database. So basically, using the client of PHP, you can perform any kind of query and parameter exposed by all the REST API. And that's actually the most powerful feature of Elasticsearch. For instance, imagine that you want to provide a simple search in order to match some field. For instance, you want to search a test field with the ABC, the value that I show here. You can just provide a query in the body that match. So this is the operator. So you want to create a query that match this information, basically this key value. You can just pass this information to the search, and you will get back quite a long result that contains a lot of information. You can see here that basically you have some information like the total number of hits that are was performed in order to search the field. In this case, it's just one, because you have only one element in Elasticsearch. And you will have also this kind of maximum score that is a double number, so a floating number, because in some way Elasticsearch is able to provide a kind of quality information about the results. So this number are something that give you a sense of quality about the results. So you can basically order, using this indexing this number, the more relevant results compared with the less relevant results. So this is actually very interesting, because you can order, you can have a sense of again, quality about your results. So basically, the results itself is under the its array, under the sub array its. So its will contain actually the results of the documents. You can also, this is a actually interesting feature of the client, because sometimes if you navigate into Elasticsearch documentation looking for a specific API, you will see that also in the manual of Elasticsearch, you will have some example with some JSON documents in order to perform the query. If you don't want to create, to map an associative array in PHP in order to call the API, you can even pass directly the JSON representation. For instance, here in this example, we are storing the $JSON, actually a JSON document, as you can see here. So this is basically a string. And we are passing this string as a body. So you can literally pass a JSON string in the body and perform the search operator. This is perfectly fine with the PHP client. So basically, the PHP client is able to recognize if the body is an array or is a string that contains a JSON, basically. So it will automatically perform this difference. Another interesting feature, when you perform some search, for instance, imagine that you have a lot of an e-commerce application where you have some products. So if you manage everything using Elasticsearch, basically you can perform some very amazing operation about searching, and you will have a lot of results. Of course, we cannot send all the results in a single HTTP response body. So we use this techniques of scrolling, or pagination, basically. So basically, you can scroll with, you can navigate to paginate in all the results of Elasticsearch. It's more efficient than regular search because if you use the scrolling inside, this is basically inside the Elasticsearch, it doesn't need to maintain all the expensive priority queue in order to perform the operation. So scrolling is very, very performant in this way. Basically, the idea is that scrolling works maintaining a point-in-time snapshot of the index, because every time you basically perform a search, the database of Elasticsearch can change, of course, in the meantime when you are scrolling the information. So in order to provide, a consistent response, basically, Elasticsearch provides a snapshot in time of this search execution. So basically, all the pagination will be compliant with this point in time. So you cannot have strange results if the database in the meantime is changing. So the search is always, aligned with this idea of snapshot. This in order to provide basically a consistent results. Basically, if you execute a scroll using an API, you will get back a scroll ID. So this is information. Scroll ID is used to find the pagination. So when basically the bookmark where you perform the research, you get the first 10 results, and we provide a scroll ID. If you again call the next API passing this scroll ID, you will get the second page of the results, and so on. So this is a very simple example. Imagine that you want to scroll all the results of a query that is basically match all. So basically, this is kind of select star from table if you think about a database, a relational database. This is the size of the scrolling. So you want to get pagination with 50 documents on each page. And this is the scroll timeout, so 30 seconds, basically. You perform a search, as usual, and you can iterate, actually, using this while loop inside the results. So, for instance, here we are saying if it's set hits, so if there are any kind of results, and if the count of the results is greater than 0, so if that means it's not empty, basically, the results, so please perform this operation. And as you can see, we are not using anymore the search API, what we are using the scroll, because now we want to scroll about the results of the previous search. So that's where basically the snapshot idea is used, because when I use a snapshot, I'm searching, I'm scrolling against this point in time search. So this is very important. So in the scroll, as you can see, we are passing the scroll ID. So the only information that actually we need in order to navigate to the other page is just this bookmark, this scroll ID. And of course, we are using the previous scroll ID. So if we loop using these techniques, basically we can have a pagination of all the information. So it's very, very simple to use scrolling to perform a scrolling operation in Elasticsearch with PHP. Okay, so this is actually one very cool feature of Elasticsearch. By default, Elasticsearch is able to provide a fuzzy search. What means fuzzy search? Basically means that when return documents, we are searching for documents. We want to find a document that contains term similar to the search query. Similar means not exactly the same, because imagine that you are building, again, the same example, an e-commerce application, and you want to be able to provide a search fuzzy feature. That means if someone writes inside the search box the name of a product with some mistake, with a missing letter, or reversing the order of some letter, with minor typo information, Elasticsearch is able to find the term that are similar to this one that you write. And how is able to do that? Using the Levenstein distance. That is a famous distance used in order to match if a term, a word is similar to another one. So basically, you can have this edit distance, that is the number of one character that change needed to turn one term into another. So basically, if you want to have some metrics in order to measure the similarity between two string, you can use these techniques. Let's give you an example. If you, for instance, you want to search for the fox string inside Elasticsearch, so we are looking for the fox term, but someone write box instead of fox. In this case, the Levenstein distance is 1, because you just need to change one letter, B to F, in order to obtain fox. So for Elasticsearch, box, if you perform a fuzzy search, will find also fox, because the distance is 1. You can even have a similarity between two strings if you remove some word. For instance, imagine that someone write black into a search engine, and you want to be able to find also the term lack. So removing basically the first letter, because the distance is 1, you basically will get this information. Elasticsearch will provide lack as a result. Again, because the Levenstein edit distance, you can have also an insert, a new character. For imagine that you are starting to write. This is also useful for auto-completion. Imagine that you want to start, implementing auto-completion using Elasticsearch. You can just perform a search operator, and if someone is start using writing a sick, for instance, we will find the sick term in Elasticsearch, and so on. So sorry, there is another one last scenarios for the Levenstein distance when you transposing to adjacent character. So imagine that you want to find a cat in the term in the search engine. If you flip the C and the A, so basically act, and if someone write act, Elasticsearch is able to find also cat, because the distance of splitting just one character is the distance is 1 according to the Levenstein definition. So if you want to perform a fuzzy search using PHP, the only things that you need to add is basically the fuzzy key. So inside the query, as you can see, we are always in the body. We have a query as the previous example. We are just putting another term here that is fuzzy, and you have to specify the name and the value that you want to look for. So very simple. In this case, imagine that you have in Elasticsearch 3 documents with this string. Document 1 is I will marry you because I love you. The second document is I will live with Harry, and the third is I'm sorry for your loss. If you insert Harry, basically Elasticsearch inside is going to perform all this Levenstein distance. In case of the first one, document 1, if you look carefully, you will see that we have Mary, that is 1 distance to Harry, because it's the first letter, H and M. So because the distance is 1, it will pick up in the results. So the first document will appear in the results of this search, of this fuzzy search. The second document, there is no, basically the distance is 0 in the sense that is equal, because we are looking for every value and the document contains the every term. So that equals is 0, and of course this will add as well in the results of the search. The last document, there is no Levenstein distance 1, because the more close actually is the Harry and sorry here, where basically if you change the first 2 characters here, Harry will become sorry, but the distance is 2, and because it's 2, by default the Levenstein distance of Elasticsearch works with 1, so this will not appear in the search results. So again, this is a very cool feature that you can use in order to perform fuzzy search. I mentioned when I start the presentation that you can perform asynchronous operation using the PHP client. Basically, the client offers a mode that is called future, that is asynchronous mode. So basically, this allows to perform batching processing of requests. So you can literally send in parallel as many API you want to Elasticsearch. So this can have a dramatic impact on the performance and the throughput of your application, because imagine that you need to perform some operation that, of course, there can be performed in parallel, of course. Using this feature, you can actually use the Elasticsearch PHP client and perform all the API in parallel. So you don't need to wait to the response, of course. As you know, PHP is fundamentally single thread. However, because we use libcurl inside the PHP implementation of Elasticsearch, there is a function called multi-interface. So I strongly suggest to have a look if you are interested, because it's a very nice way to perform a parallel HTTP call using PHP. And we use this approach in our client. So basically, if you want to perform an asynchronous HTTP call to Elasticsearch in PHP, you just need to add this client future lazy information. So basically, the client key is when you want to change the configuration of the HTTP client in PHP, in the Elasticsearch PHP. And if you pass future lazy, so this is the key, the information that means, okay, I want to use a future. As I mentioned, future is the name for the asynchronous in Elasticsearch PHP. So basically, when you will perform, in this case, a get, so you are reading some information, you want to read some information from Elasticsearch, when the PHP will execute this line here, get, the execution will not wait for the response. So basically, the execution of PHP will continue going back, unless when you want to read actually the information of the results that I call it here $future. Imagine $future is just a variable in PHP. When you read the $future underscore source, actually at this moment the PHP client will get the response. So imagine that from this line to this line, you have a lot of other feature, function, execution. Everything will continue to work. And when you want the response, so when you read this associative array, you will get back back the results. So basically, when you perform this, you block the execution, because of course that means if the result is not yet completed, I will wait for the results, because in this exactly moment I need the results. Unless you don't read this, the execution is not blocked, so you can do whatever you want after. You can also actually, this is an example. Imagine that you want to index 1,000 elements using this asynchronous approach. So basically, you can perform a for loop of 1,000, and you can store all the results in an associative array, for instance. Or this is not an associative array, sorry, this is a basic array with a number as an index. So basically, we are storing all the results in this array. You can force the resolution of a specific results, specifying this using this function wait. So when you want the results, for instance, of the 1999 documents, you can just perform a wait, and inside the futures 99, you will get basically the body. Anyway, if you are curious, this is just a very short introduction to this asynchronous way to perform HTTP call. But if you are curious, you can go and reading more information on the future mode. And by the way, the slides of my presentation will be, of course, available online. So whenever you will see an hyperlink, you can click and go to the specific information. Okay, I almost finished my presentation. I would like just to mention a couple of things where we are working on Elasticsearch, the new generation of the client. So because we want to ship a completely new Elasticsearch client for the next year, basically, when we have Elasticsearch 8 come out. So what we are doing, we are basically doing a lot of work in order to use the latest technology of PHP, of course. And we want to use the PSR standard. So that means we want to use PSR 7 for HTTP messages. We want to use PSR 3 for logging. And by the way, we are already using PSR 3 for logging. We want to use PSR 17 and 18 for supporting HTTP factories and HTTP clients. And that means the new client will speak by default PSR standards. And this is actually good because you can will be more open, basically, the architecture of the new PHP client. And by default, we will use Ghazal as the default HTTP client library. So if you don't pass, of course, you want to change the HTTP client, you can pick up any HTTP library that supports PSR 7 standard and actually inject this into the client. So we would like to reuse this idea of openness of the library. So the library will be open to change, to be configurable, to be changed as like you want. And of course, we will continue to offer asynchronous HTTP call because we think that this will be also interesting, especially using new framework for asynchronous, like, for instance, Swall. As you know, Swall is a very cool extension for PHP that gives you the possibility to write asynchronous code in PHP itself. So if you are interested in this application, of course, and you have the Elasticsearch PHP client that is able to perform asynchronous operation, this will be very, very nice to have. Okay, so basically, I finished the presentation. If you are curious for more information, of course, you can pick up me on online, on Twitter. You can find my name online. But of course, more important, you can focus on the documentation. We have a very extensive documentation about the Elasticsearch PHP. So we have a lot of documentation, and of course, I strongly suggest to look at the GitHub repository of Elasticsearch for PHP. So thank you for your attention.
Thank you so much, Enrico. Is there any questions? Pessoal, vocês têm alguma pergunta para o Enrico? Aproveitem aí o tempo que o Enrico está dedicando para nós. Let's see if we have some questions. I always tell them that their messages are important as well, since the chat goes with the video when the video is published on YouTube. So yeah,
I'm reading some. Sorry.
Go ahead. Sorry.
I'm reading some question actually about the presentation. So there is a question of number 251. I don't know who he is. Can I configure the fuzzy distance to some value different of 1? Yes, you can. But this is something dangerous in the sense that you can expect, if you put to 2, for instance, in the example that I show you, you can expect a lot of more results. So you need to be carefully to use a different value of 1, because otherwise you write something. Imagine you are building a search engine, you write something, you will get a completely different results that is not relevant. So you can, but you need to be careful on the on the results. I'm trying to read other question. Enrico, congrats for the presentation. Thank you. Number 004. You have information localization project template for download and test. I don't know what this means actually. So 004, if you can write more about the question, because I didn't understand what this means. I'm trying to figure out if there are other questions. Number 156. Great presentation, thank you. I have a question. Does Elasticsearch have anything similar to information schema like in MySQL, so that the structure of existing object can be analyzed without necessarily knowing what's inside? Yes, of course. I mentioned that it's kind of NoSQL database, but there is a mapping. So sometimes, the NoSQL database are named schemaless, but this is exactly not true, in the sense that a schema, there is always inside the engine. But for instance, if you don't pass any mapping, any schema to Elasticsearch, Elasticsearch will try to understand, will try to build a default mapping for the data that you pass it. So for instance, if you pass a string that contains a date, time, Elasticsearch is able to recognize, oh, look, this is a data time, so I will put mapping to the date timing. So that means there is always a schema inside Elasticsearch. You can actually override or pass a specific schema in order to help Elasticsearch to understand better the data that you're putting into Elasticsearch. And if you do that, you can actually have very, very great performance boost, because you are helping Elasticsearch in some way to understand your data. And at the same time, you can customize, as you said, with a kind of information schema in using the same idea of MySQL. Okay. I'm trying to read other question. 061, I guess he's asking for a template project just for ring. Okay. Sorry. Now I get the question. No, actually, there is not a template project provided by Elastic itself. I'm thinking to write one, actually, and this can also be interesting as a community project. So I will shortly invite you to send me an email or picking up on Twitter, whatever you want, to contact me in order to start, because I was thinking that maybe this is something that can be useful for a lot of people. So I have a skeleton, a simple application in PHP that perform, I don't know, a simple CRUD operation on an Elasticsearch with a search feature inside, like fuzzy feature or fuzzy search. I think will be interesting. So thanks for reminding me of doing this. I don't know if we have other minutes for question. Actually, I read only one more question. Any idea when Elasticsearch will be compatible with PHP 8? I think a couple of days, because we have a pull request from community, so I just need to finalize it and merge it. So in a couple of days, week, I'm sure we will have the support of PHPA. You're welcome. 189.
Oh, this question by 251. It was asked before. I think it was missed. So
okay.
feel free to answer. Okay.
Okay, there are any option to phonetic search? Yes, there are also feature of phonetic search in Elasticsearch. As the example that you Joao Luiz, I don't know if my Portuguese pronounce is correct or not. By the way, there are a lot of feature that you actually perform using a phonetic search. But of course, I didn't cover it, so you can have a look at the documentation of Elasticsearch itself.
Pessoal, nós vamos encerrar agora. My friend, thank you so much again for sharing the knowledge and dedicating the time to be with us today. As you know, I'm a big fan of your work, and it's always a pleasure to have you. And we hope that next year we can have you again in presence in South Brazil.
Yeah,
it will
absolutely.
be great to have you.
It would be amazing.
Yeah.
Really look forward to it. Thank you.
For us as well. So that's it. I'm stopping the recording. And
bye to everyone.